Alright, so we've covered a lot of material and it's time for a challenge. Your challenge is to create 4 new variables. A byte variable, set it to any valid byte number, it doesn't matter. A short variable, set it to any valid short number. An int variable, set it to any valid integer number. Lastly, create a variable of type long. Make it equal to 50,000 plus 10 times the sum of the values of the first 3 variables, your byte, your short and your int values. In other words, use the variable names in your expression to calculate the sum. Pause the video now and I'll see you when you get back. Alright, how'd you do? Were you able to figure that out on your own? Let's walk through the solution together now. You will find that as the challenges get more complex, you may do it one way, or I might come up with a different method. This is not only perfectly valid, it's a great way to discover multiple ways of getting one task done and should increase your learning. No matter how experienced you are as a programmer, you can often learn something new or interesting by reviewing someone else's code. Okay, let's start off by creating our variables. We've got byte value equals 10, semicolon. Short value equals 20, semicolon. Int value equals 50, semicolon. So we've got our first 3 variables set up. Next, we'll work out how to build the expression for the last variable. Long total equals 50,000 L. I'm going to put an L there to signify it's a long data type. Plus 10L times. After this, we need to multiply that by the sum of the byte, short and int values. We can add that directly into the same statement. Opening parentheses, byte value plus short value plus int value, closing parentheses, semicolon. So that's actually one solution done in a single line. And just to confirm this, and there you can see we got the result 50,800. Even with this small exercise, there were different ways to do it. Maybe you added a variable that first summed up the byte into long variables, then included this in your expression for the long variable. Let's quickly do that. I know my challenge did not call for this additional variable, but if you did code it this way, it's valid and another good way to do it. Int sum of 3 equals byte value plus short value plus int value, semicolon. And then we can use that in the expression that we assign to the final long variable. Long total equals 50000L plus opening parentheses 10 times sum of 3 closing parentheses, semicolon. And again we get the value of 50,800. In the last statement, I added a set of parentheses around part of the equation. Parentheses are another way to make your code more readable. They also make it clear which calculation should be done first. In this case, it's a bit more obvious we are multiplying the sum of the other 3 variables by 10 before adding it to the 50,000. I also did not include the L suffix in the numeric literal 10 in this example. Remember that L is optional if the value is less than the integer maximum value. You can include it as a way of creating self-documenting code for future readers, but it works just the same without it in this instance. So, those are just 2 variations to the same end result. Maybe you came up with others. Considering the many paths to the same end result is one of the things that makes programming so interesting. Also notice how we didn't need to do any casting. This is because the right side produced a long because we used a long literal in the first part of the equation, so in this instance, the result is a long. But what if we wanted to do something similar with a short? I know this isn't part of the challenge either, but we'll just go through it anyway. It would be something like short total equals opening parentheses 1000 plus 10 times opening parentheses byte value plus short value plus int value, close both parentheses, semicolon. Enter. Now clearly we've got an error doing that, and the reason why we've got an error is it required a short but found an int. Now we do have to cast. So we need to be specific here and put a short cast in front of the expression there. Opening parentheses, short, closing parentheses. We created a short cast by adding the word short in parentheses before the parentheses that enclose the full equation. If we press enter now, we get the output 1800 and not an error. So the point of this, after solving the challenge, was just to suggest that integer is the best primitive data type for whole numbers generally. But even if you're using type long, you saw that Java handles a lot of the complexity for you, and you don't have to do this casting with a long. So that's it, 4 bytes, shorts, integers and longs, which are the first 4 primitive types in Java's list of available types. We still have 4 left to go. In the next video, we're going to start talking about decimal numbers because, of course, we've only been dealing with whole numbers up until now. Some things work fine with whole numbers, like age and air temperature, but there are many things that do not, like your bank account balance or mathematical constants like the value of pi. Conversion equations are also rarely expressed in whole numbers. For example, you might want to convert pounds to kilograms or something of that nature. In that scenario, having the ability to use decimal points in the number would be necessary for an accurate conversion. So let's start working on that in the next video.